Hi, we are officially at the end of this section, but I have decided to add one more bonus video. Now, this bonus video is all about teaching you higher order functions. Now, learning higher order functions can be a little bit challenging for beginners, so I want you to just sit back and relax and just watch as if you are watching a movie. If you can understand the concept, then it's really amazing. If you can't, there is nothing to lose. And normally it will take you multiple attempts, maybe twice or thrice before you can understand the concept, and which is perfectly fine. I don't blame you for that. The concept itself can be a little more challenging. So just enjoy and see if you can get it. Welcome to the world of functions. Let's start by understanding what are functions and how they are managed inside our memory. So suppose we have a couple of functions. So here I have defined two functions. One is hello and the next one is good morning. So these are pretty simple functions. Now let's see what's happening inside our memory. So this green area would be our memory. Now please keep in mind that this is a very simplified version. In actual life, things are much more complicated. Let's see what's going to happen now. When Python comes across this line number 3 and 4, it is going to create a function called as hello inside our memory. So this is what is happening. We have a function called as hello inside our memory. Now the next question is, how does Python know how many functions it has created inside the memory? The answer is Python gives each and every object a unique ID. Now, what do I mean by an object? Object is a generic term. Just like all of us are human beings, but we are also animals. Same thing, anything inside the world of Python is an object. A variable is an object, a class is an object, a function is an object, anything is an object inside the world of Python. So let me say Python is going to create an object which is of the type of function inside the memory, and the way Python is going to keep a track of all of the objects inside the memory is by giving each one of them a unique ID. It's just like us. Every one of us has a unique passport number. So you can say each one of us has a unique ID as well. The next question would be, how does Python know where does the object live? It knows because it allocates some address to the object. It's just like us. Every one of us has an address. Similarly, inside the world of Python, every object which is created inside the memory also has an address, and this is how it looks like. Now this format is a very special format. It is called as hexadecimal format. You can see this address always starts with a 0 followed by an X. So whenever you see this format, it means it's an hexadecimal format. It is just a way of representing the memory inside our computer. Now what happens when Python goes to next line, line number 7, it sees that we have another function. So it goes back to the memory and it creates another function by the name of good morning. Now good morning also has a unique ID and it also has a unique address. So for example, we can say good morning has this address right over here. We can see this in action inside our IPython shell. So let me open up my IPython shell. So here it is. So here I can say my definition of hello. It's simply printing out hello world. So here I'm just creating a very simple function. Let us see the ID of this function. So I can simply type, I want to see the ID of my function called as hello. So this is the unique ID of our function. You can also ask Python to reveal the type of this object. So you can say, I want to see the type of hello, and the type is a function. If you want to see the address, then we can say, I want to see the hexadecimal of the object which has an ID of hello, and here it is. So this is the address of hello inside our memory. Let us create one more function. So let me define a function called as good morning, and on the next line I can say I simply want to print good morning. So we have another function. Let's see the ID of good morning. Now you can see we have a different ID. This ID ends in 144. The ID of hello was 032. Let us also check the address of this one. So I can say hex id of good morning. So you can see we have a different address. So this is F7F0 and here it was B370. So that means hello and good morning are two different objects with two different ID and with two different address inside our memory. Let me clear my terminal and now watch closely what happens. If I create a variable called as greet and if I assign it the value of hello and if I try to invoke greet, we have an output called as hello world. So what's this? What's happening behind the scenes? Now let us go back to our diagram to understand what's happening. What's happening is Python is actually playing a trick with us. So this is the variable which we just created, but if you check its address, it has the same address as hello. So in short, what Python is doing is it is just creating a reference to hello. So the greet variable is just referencing the function of hello. It's just like sharing your house. And when we invoke this function by using brackets, so when we use the bracket, that means we are invoking. Here you can see I don't have the bracket. On line number 33, I'm just assigning the function of hello to greet. And on the next line, I'm using brackets to invoke the function. And when we invoke the function, we get the output of hello world. So what happens is when we invoke greet, it goes back, it sees that greet is actually referencing hello, and behind the scenes it's this function which is being executed. But on the scene it looks like it's the function called as greet which is being executed. Now let's get back to our code editor and start writing some code. What I've done is behind the scenes I have created a new file called as HOF. This stands for higher order functions.py, and I have created a couple of comments for us. The type of function is also called as callable. Because this object can be called, we can give some arguments to it and we can get some values from it. That's why in the world of Python, functions are also called as callables. If you're thinking, why do we need this kind of a functionality? The answer is, till now we have been passing data to the functions, but sometimes it can be very expensive. So what's the solution? The solution is passing the function to the data. You have to just start thinking in reverse. So what we are going to do is we have some data and we would be passing functions to it. Imagine you have terabytes and terabytes of data. It would be so expensive to transport all of this data from one server to the another server just for the sake of computation. Instead, we can simply pass a function to the data and we can get our job done much more easily. So let's start by creating the same function called as hello right over here. So this is the function that we created. The next point, I again want to reiterate that function is just a regular object of the type of function. There is nothing special about it. Now let us also try to print the ID of hello, and let us also try to print the type of hello. Let me run the file. So here it is. Let me take it up a little bit. Okay. So when I'm saying I just want to print hello, so hello is a function which is present at this address. The ID is this one and the type is actually a class of the type of function. Let's get back and see what else we can do. Now let's try to create a variable and assign the value of hello to that variable. So let me put a comment and let us create the variable called as greet and let me assign the value of hello to it. Again, remember, I'm not putting my brackets over here because I'm not invoking the function. I am just assigning the function hello to the variable of greet. Now let us try to invoke the function of greet. So let me write greet with the brackets. Let me save the file and let me try to run the file. So here we have the output of hello world. Let us go back and see how we can add types to all of these variables. I just explained that hello is also called as a callable inside the world of Python. So the type of greet is actually a callable type. Let me go up and let me say that from typing, I want to import callable. Now let us go down. Let us start adding our types right over here. So greet is of the type of callable. Now if you see the function of hello, it is not taking any arguments and it is returning none. So what we can do is callable. Let us put some brackets. This means that greet is of the type of callable, and inside this brackets we have to specify the input arguments and the output of the function. And here inside the square brackets, the first argument is always a kind of list, and the second argument is the return type of this function. Now let's see how we can add the types. Hello, it is not accepting any arguments, so the first argument to callable would be empty. Next, our function of hello is returning none. So here after the comma I can say it's a callable which returns none, and that's it. We have a nicely typed function as well. Let me add some comments just for the sake of reference. So here we are just assigning the values, and here we are invoking the function. Let us see what else we can do with our functions. Let me put a separator and let me put some comments. So this time we are going to create a universal greeter. Remember, I just explained the concept that we can also pass the functions to the data. That's what we are going to do right now. I am going to create a universal greeter that takes two arguments. The first argument would be for the name, and the second argument will actually take a function. Now suppose you want to greet Zola, then our universal greeter function will greet as Zola. If you want to greet as good morning, then our function will greet as good morning. If you want to greet as goodbye, then our function will greet as goodbye. Sounds so awesome, isn't it? So first let me type all of the functions and then I will try to explain all of them. Let me create the first function called as Zola. So what this function is doing is it is simply taking one argument and it is returning a greeter in the form of Zola followed by the name. Let's create one more function for good morning. The next would be for goodbye. Now let's create our universal greeter function. So let me put up a comment over here and I can say my universal greeter. So this function is going to accept two parameters. The first parameter is the name, and let me get the spelling right, string. The name is of the type of a string. Now what should be the next argument? The next argument is of the type of a function. Let me name it as greeter. The type of this is callable. Now let's see how we can define the types inside callable. Look at all of the functions which I've created: Zola, good morning, goodbye. The function signature is common. All of these functions accept only one parameter, that too of the type of string, and all of this function returns a single argument which is also of the type of string. So that's what I'm going to pass right over here. Let's see how we can define the types. So the first argument is a list and the second argument is the return type. All of the functions are returning strings, so I can just write string over here, and all of the functions are also accepting a string. So inside my inner brackets I can say string. So this is called as a function signature. All of this function accept one string and return one string. Same thing we are saying over here. Our callable accepts one string and returns one string. Now let's see how we can define the body of this function. Let me add some documentation. Now here you would be amazed, it is just 2 lines function. The first thing that we want to do is let us take the function of greeter and pass it the argument of name. That's it. That's the entire logic. Let me assign the output to a variable called as message, and on the next line let me simply print it out. Just save a file. Let me try to run the file, and after that I will again try to explain what's happening. But before that I want to comment all of these things. Let me comment out all of this. I don't need all of these things. The greet function as well. Let us invoke our universal greater function, and then we can have a nice output. So let me go right over here, and here let's see how we can invoke the function. So let me say universal greeter, my name is Octallium. Now let's see what we can pass as the second argument. If you see right here, my IDE is telling me that greeter is also a type of function. This brackets, it denotes a function, it takes a string and it returns a string. So basically we can pass any functions that satisfies this signature. And luckily all of our functions, Zola, good morning and goodbye, satisfy these conditions. So we are going to pass one by one inside the universal greeter. For the first one, let me pass simply as Zola. Now remember, I don't have to put brackets because I am not invoking. I simply have to pass my function and that's it. Let me copy and paste. Let me take a little up. The second one would be good morning. The last one would be goodbye. That's it. Just save a file and let's try to run it, and hopefully this time we should have a nice output. Wow, it's so amazing. Single function can produce multiple outputs. Now let's see behind the scenes what's exactly happening. For example, let us take just this line number 65. So Zola is actually a function and this is how it looks. Now let's go back to our definition right over here. This Zola comes as a function called as greeter inside our function. Now this greeter is just a reference to the function of Zola. Let me open up my diagram one more time. So imagine this to be our greeter function and this to be Zola. So greeter is just a reference to Zola, and whenever we invoke this function, behind the scenes the original function is being evoked. So let me go back to my code. So you can see on line number 61 we have a new variable called as greeter. So this greeter is actually a reference to Zola. We pass one argument of name to the function. This name goes right over here, and if you see the function definition, we are returning a string called as Zola followed by the name. We are saving this string inside a variable called as message, and we simply want to print it out. This is happening with each of the functions. The second time what happens is we are passing good morning. Now the second time this greeter over here, this references good morning, and what good morning is doing is it is simply returning a string good morning followed by the name. We capture this output inside this variable right over here and we are printing it out, and the same thing goes with goodbye as well. That's the reason why every time we have a unique output. First time greeter was referencing Zola, so we have Zola Octallium. Second time it was good morning, so we have good morning Octallium, and the last time we had goodbye, so we have goodbye Octallium. Sounds pretty neat, isn't it? Now let's get back and let's try to learn a little bit more about functions. Let me put a separator. A function, as we saw, can accept a function, but a function can also return a function. Now this part really took me a couple of attempts to understand, so if you can't get it, don't worry, you will eventually get it. So let's go down and let's see how we can create a function that accepts as well as returns a function. Let me put up a comment. Let us see how we can create a function that will return us a function. Let me define a function called as add by 5. This takes one argument number which is of the type of integer. Now since this function actually returns a function, so we can say this is going to return a callable, and we will define the types a little later on. Right now just go ahead and let us type the body of the function. Let me add some documentation. Now what I'm going to do is I'm going to create one more function inside this function. So let's create one more function. Let me create a function called as by 5, and this actually does not accept anything, and this function returns an integer. inside this, let me say I want to return the number that we get right over here. So I want to return that number plus of 5. So this is the function inside this one. And since our outer function, it has to also return a callable. So we need to have a return statement. And this time I am simply going to return my function, which is going to be this one called as by 5. First, let us see the type hinting, and then we will try to understand what's happening. So let me go back to this line. So we know that this function is supposed to return a callable type. Now this callable type is actually this function. So now we can start adding types to it. So here goes my brackets. The first one is for the inputs. After the comma is for the output. This function is returning an integer. So let me write int over here. And this function is not accepting anything. So this argument remains blank. Just save a file. So this is also called as your higher order function. Let's see how we can work with these functions. Let me say that a new variable called as sum is equal to my function of add by 5. Let me pass an argument of 5. If you just hover over right over here, so your IDE is also telling you that the return type is a function which accepts nothing but returns an integer. So what's happening is our variable of sum now, this is referencing to this variable which is inside. We can also invoke sum, and let's see if we are getting the right output or not. So I can say print and sum, and that's it. The reason why we are not giving any input right over here is because sum is referencing this function right over here, and this function does not accept any argument. That's why it is blank. Let me just save it and let me try to run this file. And here we have the output of 10. So this 5 plus this 5 is equal to 10. Well, we can also return a function that accepts an argument. That means we can create a function which can actually accept something and do with the data. So this time let us create a new function called as universal adder. But this adder is going to be a little unique. This adder is going to add two numbers and subtract by 1. It's our own adder. So let me go down over here. Let me take it up. Let me add a comment. And let us define a function called as our unique adder. Now this accepts one number. So this is going to be our first number. So let me call it as num1. The type is integer. This also returns a callable. We will add the types shortly. Let me add some documentation. Now let us create one function right over here. But this function is going to accept another number. And we are going to return this number plus another number minus of 1. So I can say define our adder. This function also accepts one argument. Let me call it as num2, type of integer, and this one returns an integer. And let us place our logic right over here. So since this is a unique adder, what we want to do is we want to add the first number, the second number, and minus of 1. Let us go below and complete the function by adding our return statement. So we can say this function right over here, this is going to return a callable, and this time this callable is going to be adder. So we can say return adder. Let us define the typing for this one. So our brackets, one more brackets inside for the input argument, and the next one for the return argument. Let us see this function. This function is returning an integer. So we can say integer right over here. And this function is also accepting one integer. So inside this brackets, I can say integer. And that's it. We have a beautifully typed function as well. Let's try to invoke this function and let us see if it is doing its job or not. So my adder would be my unique adder. Let me pass one argument of 5, and as you can see, this is returning one more function, and the function signature is integer returning an integer. Let us print out the value. Let me use my print statement adder, and here I want to give my next number, so I want to add 5 and 5. Let us see what output we should get. So I want to add my 5 with my 5 but minus of 1, so the output should be 9. So let me save my file and let us try running it, and here we have the output of 9. Let us go back and let us try to study what's happening. So what's happening is our function of unique adder is returning another function. So this adder is referencing the return callable from this function, and the return callable is this function right over here. So in short, adder is referencing this adder over here. Let us try with one more example. So let me add 4 and 3. The output should be 4 plus 3 is 7 minus 1 6. Let me save it and let me try to run it, and here we have the output of 6. Let me put it back to 5 and 5. Now let us move to the last part, which is called as a lambda. Let me put a separator line over here, and let me put some comments. So we are going to learn about lambda. Now lambdas are pretty simple, but they are often neglected. Trust me, they are not really complicated. It is just a different way of declaring your functions. Let me first type and then I will show you what's exactly happening. Let me go to the top, right over here. Now this is a function called as hello. Let us see how we can define this hello using a lambda. So I can say my new function called as hello number 2 would be a lambda. Lambda simply means a function. Now this function is not accepting any arguments, so we can just write colon, but this returns a string, so we can say this is going to return hello world, and that's it. It's so simple. The entire function can be condensed into a single line. Let me copy this and let me go back to my IPython shell and let's play over there. So let me paste it right over here, and I can invoke my hello2 just as a regular function, and we have the output of hello world. So lambdas are just your regular functions, but they are declared in a different way. Suppose this function accepts one argument, then that argument will come before this colons. Let me take it out and let me show you one more example. Let us go right over here for Zola. So I can say my Zola number 2 would be my lambda. Now this function of Zola accepts one argument as name, so I can write name, and this returns a formatted string. So let me just copy and paste it right over here, and that's it. We have a lambda function ready. Let me copy this and paste it in my IPython shell. Let me paste it, and that's it. Let us invoke this one, Zola to Octallium. I forgot to close the string. Let me close it, and we have the output of Zola Octallium. It's pretty simple, isn't it? Let me again take it out. So just for the sake of practice, let us create one function which will act like a calculator. Now just imagine your calculator. It's a single calculator, but it can do multiple functions. It can do addition, subtraction, division, and so on. So we are going to try and mimic the same functionality by using lambdas. So here, let me create my first lambda by the name of add. So I can say this is going to be a lambda. This accepts two numbers, so my number 1 and my number 2, and this is just going to return the sum. So I can say number 1 plus number 2. If you notice, we don't use the keyword of return inside the lambda because whatever value that comes after the colon, it's automatically returned. Let me save this one. Now, as a convention, the arguments for lambda functions are written as x and y, but you can write num1 and num2. But right now, just for the sake of simplicity, let me convert this to x and y. So let me do my multi-select. This argument becomes my x and the next argument becomes my y. Let us see how we can add types to our function. So as we know, lambda is nothing, it's just a function, and we know the function is also called as a callable. We can say it is of the type of callable. Now inside, the first brackets are for the inputs, the next one is for the output. Now let us see what's happening. Our function of lambda is accepting two inputs. This is the first one and this is the second one. And we want to say that both of the inputs should be of the type of integer. So let's go back right over here and we can say the first argument is an integer, the second argument is an integer as well. And we are returning a single value, so we can say this function is going to return a single value of the type of integer. And that's it. Let us create one for subtract and one for multiply. So let me just copy and paste. This would be for subtract. I just have to make a very small change. This has to be x minus, and this one would be for multiply. Again, this is x into. So you can see it's so simple. Let's define a calculator on the next line. So I can say define calc. Now let's see the inputs. So obviously we require two numbers. So I can say my first one is an integer, the second one is also an integer, and the third one is going to be a function. Let me call that function as operation. So we are going to operate on both of this number. That's why I'm going to call this function as operation. You can call anything that you want. The type of this one is exactly the type of this one. So I just have to copy and paste from here to here. Now let's go to the return type, and this is going to return an integer. So what's happening is we have a lambda, it is taking two integers and it is also giving an integer in return. So this is what we want to return. So this integer comes from here to here, and inside let me put some documentation. Here the return statement is extremely simple. We simply want to execute the operation on both our numbers, so number 1 and number 2, that's it. And we simply have to return the output. So I can say return, save your file, and we have a nicely defined calculator as well. Let's try to invoke our function and let's see if we are getting the right output or not. Let us try adding 4 and 5. So I can say I want to print the output of my calculator. I want to add 4 and 5, and the operation here is going to be this add operation. So I can just pass that function right over here. I can say add. Next, let us do subtract and multiply as well. So this will be subtract and this would be multiply. Save your file and let us try it running for the last time. And here is the output. 4 plus 5 is 9, 4 minus 5 is minus 1, 4 multiplied by 5 is 20. Well, that's it for this video. I hope you really enjoyed working with functions. More you start practicing with functions, more you will start loving them. And once you are hooked to functions, you may never want to go back again. And if you want to learn the functional approach of programming, then perhaps Python may not be the right programming language, because Python is an object-oriented language. If you want to learn more about the functional aspect, then you can learn languages such as Elixir, Haskell, and Scala. Those languages are built around the functional approach.